Hey everybody, I'm Mr. Hartzler, and I want to talk to you in this video a little bit about conic sections overall, and then we're going to dive specifically into parabolas. So this is going to be for my students in Algebra 2 honors, and it works for really all Algebra 2s, and in my particular case, it's going to be Chapter 9, Section 1. So let us get started. I'm going to share my screen with you so you can check out what I'm doing. All right, so I wrote up a little bit already, so let's talk about some of these things. So first off, where do conic sections even come from? And it's really from this shape you see over on the left side of your screen. Can't remember the shape or what the name of this shape is, but think about a cone stacked on top of another cone. Okay, so these are both three-dimensional, though I'm not, phenomenal at drawing three-dimensional shapes, right? But 3D on top and bottom. So if I take that shape and I cut it, let's use, I've got blue here. To make a parabola, I would cut this shape maybe here. So now I think about a cross section, okay? So I've got that bottom cone, and I just cut a little slice out, super thin. Pull that out, and that shape that would come off of that would be a parabola. Now, if I cut it a little bit differently, right? If I cut it straight across, let's do it up at the top side this time, right there. If I cut out just a thin slice right there and pull it out, then that would be just a perfect circle. So that's kind of cool. And then if I were to do the orange one over there, an ellipse, that is from cutting it up here a little bit. So I'm doing a shallower cut. Now that one is going to end up looking like an ellipse or an elongated circle. So it doesn't just have one center. It actually now has two what are called foci, which is the plural of focus. So that's how an ellipse is created. But it is a shallow horizontal cut there. So let's now look at the, burgundy one. It's a dark color. But this is a hyperbola, and that's if I do a vertical line right somewhere maybe over here. So I've got a parabola from the top chunk, and I have a parabola from the bottom chunk. So I actually have two of them. Either on top and bottom or left and right. So I could have also, let me undo that one. If I cut it horizontally, sorry, now I end up with a circle. But there are different ways of cutting it so that these hyperbola actually open up left and right. So that's kind of fun. Part of that depends on how I'm orienting my shape there. But all right, so let us clear this one out, and I want to talk to you about a couple of specific examples. Like I said, we're going to dive into parabolas. So let's look at parabolas. First off, it's going to take on the form usually of this: y equals a x minus h squared plus k. So if you're one of my students, this seems familiar, right? We've talked a lot about this. You've looked a lot into the parabola, but we're going to dive a little bit deeper. So I do want to point out a couple of the classics because some of you might not remember. A is our amplitude, or how steep it is in general. H is part of our vertex, and K is part of our vertex. And we put that into H comma K, and it is our vertex. Okay, so there's that little chunk there. Remember, because the H is in parentheses, it comes out and becomes the opposite of whatever it was. So in parentheses right now, it's a negative H. It's going to come out as a positive H. I know it trips everybody up, but that's okay. I do want to point out another formula, and this is going to come into play later, but you should write it down now. So A equals 1 over 4C. C is the distance between our focus and the vertex, is distance between vertex and our focus. Now, it is important because, right, I just said focus. You haven't learned that word yet, probably. So I do need to bring that up. But if I bring up focus, I also have to bring up directrix. And C is also the distance between the directrix and the vertex. Okay? So it serves both purposes. But I need to show you a little bit of an example for us to really grasp that, I think. So I'm going to change it to blue. And I'm just going to draw us a pretty classic parabola. Boom, there it is. It opens to the right. So this one would actually be a x equals y squared situation. The classic one, I'm going to do this up on the left side of your screen, that goes up and down. That's a y equal x squared. Ooh, I don't know what I just did there. Y equals x squared kind of situation. So I open left to right, so it's a x equal y squared. My focus is, we'll say here, I represent my directrix by a dotted line. It is a line, and focus is a point. Okay, so here is my focus, and here's my directrix. Any point on my graph, let me switch colors here. Let's say this one. See that red dot right there? See it? Cool. So if I draw a line from there to my focus, that length would be C. If I drew a straight line from my red dot, or any part on my graph here, to my directrix, that distance would be C. Okay, so that's kind of the relationship there. My curve to my focus is going to be equal to the distance between that same point on my curve and the directrix. The directrix is a line, so in this case, it would be something like x equals, we'll just call this 1. Okay, and my focus, because there may be, this is over here at 2, and then this would be at 3. So my focus would be at the coordinate point, in this case, 3, 0. Okay, so this is focus, and this is directrix. Just to kind of throw that out as a quick example, let's actually do a better one here. So let me clear the screen for you. And let's look at one of these examples. So if you're one of my students, this is going to be example number 1 on the practice sheet I'm giving you. So I'm going to tell you that the focus is at the coordinate point 0, 4. And I'm going to tell you that the directrix, just a fun word to say, is at y equal -4. Very first thing that I'm going to do nearly every time, right, is draw this. So focus at 0, 4, that's over 1, 2, 3, 4. Ooh, actually, it's not, right? X comes before Y in the alphabet. So I'm actually left and right 0, up 4. So I go up 1, 2, 3, 4. There's my focus. Directrix is y equals -4, so that's down 1, 2, 3, 4. Remember, directrix is a line. My focus is always inside my parabola. That means that I know this graph is going to go up. My directrix is going to be outside my parabola. My focus is going to be inside my parabola. So it has to work this way. Otherwise, if it were left and right, I would eventually cross my directrix. Not going to happen, because then my distance to my directrix would be 0. Can't happen. Okay, so I know I open up and down. That means that my formula is going to be something like y equals x squared. So let us then see how we figure that out. And it's actually going to be using the distance formula. So quick reminder. Excuse me, I think I have the hiccups. Distance formula is x minus x1 squared plus y minus y1 squared. All right. I know a bunch of this information. You might not think you do, but you do. Your focus, right? It gave you a coordinate point. It gave you an x and a y. And any of the numbers that they give you are going to be this x1 and y1. So you'll notice I have a y over here with my focus, and I have a y with my directrix. So I'm actually going to set 2 distance formulas equal to each other. So let me write that down here. I'm going to do this one in blue. Okay, so I have x minus x1 squared plus y minus y1 squared. And that's going to equal the same thing, right? And there's a square root over all of this, but that square root's going to cancel, so that's sweet. X minus x1 squared plus y minus y1 squared. Now over here on the right, this one's going to come from my directrix. And the one on the left is going to come from my focus. So over on the left then, let's simplify that. Hopefully we can all figure out here that if I square both sides, I cancel my square root. So I'm not going to deal with the square root anymore. So let's have, this is going to be x minus x1 coming from my focus. So that's a 0. Plus y minus y1 comes from my focus. So it's 4. Equals. Now, the right side, that comes from my directrix. So x minus, what's it say my x is? It doesn't. I know, right? How great is that? So if it doesn't tell me, I'm just going to leave it as x squared plus y minus, it told me a y value, so that's going to be a negative 4. Yes, it ends up being double negatives here. Don't be frightened by that. All right, now I'm just going to solve this like normal, and some beautiful things are going to happen. X minus 0 is x. So x squared is x squared. Now this one, x minus 4 squared, you have to FOIL this. If you don't remember FOIL or don't know what the acronym is, it is just an acronym to help you remember. You have to multiply this as two separate things. First, outer, inner, and last is what it stands for. So I have to do, actually right over here real quick, just to show you this one time, and I'm not going to show you again, okay? Y times y, and then y times negative 4. Negative 4 times y, and then negative 4 times negative 4. That's how this is all going to happen. Y squared minus 4y minus 4y plus 16 because double negatives. I'll let you rewind that and watch that again if you need help. Of course, email me, folks. That's what I'm here for. This is what it's going to simplify to. So I'm just going to straight up write that down over here. Equals x minus x is 0. So 0 squared is still just 0. I'll write that just for fun. And then over here, this is going to be y plus 4. It's similar to this on the right side. We would have to FOIL that. Not going to show you this time. I'm just going to do that math. So that's y squared. That's a plus 4, remember. So it's going to be plus 8y and plus 16. Now let's look into this. A bunch of stuff cancels, right? I have a y squared on one side, y squared on the other. Cancels. I have a 16, and I have a 16. Cancels. What am I left with here? X squared minus 8y equals 8y. For the love of goodness, don't tell me that negative 8y and positive 8y, opposite sides are going to cancel. One's negative, one's positive. It's a no-go situation. Add this 8y over. Oh. Yeah. Did I forget something? No, we cool. We cool. Okay. So I added that 8y over. So now I have x squared equal 16y. With me so far? Cool. If not, that's what YouTube's for. Rewind. I'm just going to rewrite that exact same thing right here. Just ran out of room. All right, folks. Now I am going to switch to green. And I'm going to solve for y here. The reason I'm solving for y and not for the x is because the y doesn't have an exponent on it. Well, it does. It's a 1, but it's not squared. So y equals 1 over 16 x squared. That is my answer, okay? We be done. I know that seemed tricky, but remember, you're just using the distance formula. You're going to plug your focus, where's my cursor? There it is. Focus onto the one on the left and your directrix into the one on the right. And if it doesn't give you, right, this one just gave me a y equal negative 4. So I'm just gonna leave an x in there instead of x1. Okay, so just treat those now like they're the same, the x minus x. It works the same if they give you a directrix as an x equal, except you would just have a y minus y here, okay? Hopefully that was helpful. I'm going to save this and I'm going to clear it. Boom, gone. Magic of technology. I want to show you another example, and this one is based off of a graph. So let's try and make a pretty graph. Okay, not too bad actually. 2, 3, 4, 5 over 5. This is my focus, and I'm going to make that a different color, an obnoxious color. Let's make it this bright red. And I'm going to make my graph, and it's going to be and whoosh. I like sound effects. If you're not doing sound effects and you're drawing graphs, then you just living a sad life. Okay, so focus. There's my graph. Yeah, I'm not telling you to focus. I'm just pointing out my focus. Sorry, I've been here a lot. Okay, so if my focus is 5 away, common sense now tells me my directrix is 5 away. So boom, we got that sucker. But let's keep doing some work, right? One of the things I'm going to try and find when I'm trying to figure out this whole deal is, well, I know where my vertex is first. That's kind of nice, right? I told you way at the beginning, y equals a x minus h squared plus k. but we open left and right. So we actually have a slightly different formula. Or x equals a, y minus k squared plus h. Okay, so in here still, we are going to have our h and our k. So k is now with our y. It's always hanging out there with our y. FYI, y and k always together. But I'm at my origin, so I already know pieces of this. I know that it's going to be y minus 0 and then plus a 0, because I'm not shifted left or right any, so that's kind of nice. I know my vertex is at the origin. Helpful. It told me this piece and this piece. Now I need to solve for a. I need to figure out where that sucker is at. And I can do that, but first I'm going to have to do this with my c value. Remember, c is the distance between my vertex and focus. There we go. So my distance from here to here is how much? Solid arrowheads, there we go. Well, it's 5 units over. So I know c equals 5, but I told you earlier, right? So you can rewind there. And I also told you that c equals 1 over 4 times a. No, sorry. A equals 1 over 4 times, I did that wrong, times c. Okay, so this is an a. So I can solve a little bit now, right? I know some of this information. I'm going to plug that c in. So I know a equals 1 over 4 times, well, what is my c value? That's a 5, and it is on the denominator, by the way, there. Okay, so my a value is now 1 over 20. That can be kind of helpful. Again, that just came from knowing the distance between my focus and my vertex. I would be doing the same thing if it was the distance from my directrix to my vertex. So that was still a unit of 5, right? They're both the same. Cool. So now that I have a, I can substitute that in up here. So x equals 1 over 20 times y squared. Again, right here, pointing this out, it is an x equals y squared situation because it opens left or right. And because this number, this 1 over 20, is positive, I know it opens to the right, and vice versa. If I know it opens to the right, then I know my amplitude must be positive. Okay, let us move on. I'm sure this is getting to be a long video. Recording this using Zoom, and it just straight up don't tell me. But I want to do one more. This one's critical. We've done similar things to this before, but I want to point it out again because you guys forget stuff so stinking fast. So the last one was number 4. This one's going to be number 7 on the problems I'm giving my Algebra 2 students. Yeah, I'm giving you the answer. Write this sucker down. 0 equals negative y plus x squared minus 6x plus 2. Yeah, I know un poco español. All right, let me solve this for y. I'm doing it for y because it doesn't have an exponent on it. Yeah, sure, this x over here doesn't either, but this x does. Pick the one letter that doesn't ever have a square on it and solve for that one. So I'm going to add the y over. This is called, just so you know, completing the square. Been a while since we've done it, but yes, we have in fact done this. All right, so now we're here. This is where some of my students fight me on this because they don't like that I actually use a square, but I actually use a square. Why? And you know what? I won't use a square. This is for Allie, okay, and Katrina. They both just hated that I did squares. So I'm just going to leave myself some space, okay? That's all I'm doing. You'll notice both those equations, the blue one and the green one, exactly the same, except I've added plus and then a space and then a plus and then a space. Nothing wrong with that, right? But now let's do this in orange. The thing that goes on that line, that space, or back in my day, I used to actually do a square until people got mad at me. I'm going to take this negative 6. It's always that negative 6. It's always the thing that's just connected to the single term there. Negative 6, I'm going to divide it by 2. then I'm going to square it. Yeah, it's maybe coming back to you right now. I bet a couple of you just had a light bulb go off. Negative 6 divided by 2 is negative 3. Negative 3 squared is a positive 9. Double negatives. You can check it out. So this is a 9. This is a 9. Okay. That is perfectly legal. I know it seems all kinds of sketchy, right? You just added a 9 in there. You just created it. And yes, you did create it on purpose for a specific intent, which is awesome in a second. But you created it, and that's perfectly fine as long as I do it to both sides, right? I could do almost whatever I want as long as I do it to both sides of the equality. Okay. Now, see here? Ignore the 2 for a moment, okay? He was there originally. He's just hanging out. Ignore him for a second. Factor this set of parentheses that I did in orange. So left doesn't change. The parentheses here, they become x minus 3 times x minus 3, or x minus 3 squared, right? You did that intentionally. That's the great thing about it. You created that 9 with a purpose of being able to split it up like this. It'll also always work that this negative 6 divided by 2 gets you this answer. So that's kind of cute, especially when it's a fraction. Saves you a second or two of thought. I know a lot of you like that. All right, so now, oh, I shouldn't go back to green. I was just at green. Now I'm going to solve this y by itself again. So I'm going to move that 9 back over. So now y equals x minus 3 squared minus 7. The great thing is we now have it in what I like to call vertex form. Books will switch this up all the time. The one I was taught, this is vertex form. It makes sense because you know the vertex like super easy. Some books call this standard form, and the general form being the one that would be like y equals ax squared plus bx plus c. So they would call that one general and this one standard or something. But I call this one on the left vertex form, and all of the other ones are crap. So I just don't even use them. All right, let's just erase that. That's an annoying one that gets in the way sometimes. All right, so we have it in vertex form. That means I know the vertex, right? Boom, right there. Pull these numbers out, the 3 and the 7. Remember, the 3 was in parentheses, so it switches signs. The negative 7, he did not have parentheses, so he stays the same. So I know my vertex. I can find my focus. Remember, that is c away, the distance c away from my vertex. So first off, I need to figure out what this looks like. So it's a y equals x squared situation. So it's going to open up. The vertex is 3, 7. So it's over 1, 2, 3, and down 7. So I'm just going to put that there. Whoop and woo. Remember, you have to do sound effects, otherwise you're not doing it right. And my vertex, or my focus, sorry, is going to be somewhere up in here. Focus is always within my parabola. So I know that it's going to be that 3 for my vertex, and I'm going to be adding whatever my c is to it, and my y is going to be unchanged because it goes straight up from my vertex. My directrix is going to be a horizontal line. Horizontal lines are y equals situations, and that's going to be then this negative 7, and I'm going to be down, right? Down the same distance I am up to my focus. So I'm down an extra c value. We need to figure out what c is, right? Well, if I look at my formula from before, a equals 1 over 4c. I'm going to do that old cross multiplying trick, right? 4c times a equals 1. Oh, sorry. We know what a is. Let's go backwards a little bit. Oh, okay, here we are. Let me erase this a, because we know what a is. A is my amplitude. It came from my formula. It's sitting right out here. It's a 1. So cross multiplying out gets me 4c equal 1 divided by 4. So c equals a 4th. So here, I am going to tweak this, erase that c and erase this c. And I'm going to write in that 1/4. Okay, so that kind of shows you where all of those little pieces and parts came from. All right. All right. I think we're good. I think I did it all. Did I do it right? Yeah, I did it right, I think. I don't know. If not, leave a comment. That'll tell me I'm wrong. All right. I hope this was helpful. Let me save this sucker and let me end this screen share so I can talk to you. So if you're one of my students, please send me an email if you have questions. If you're not one of my students, or if you are and you're not super curious about anything, you just don't care when you get an answer, then type that in the comments below. If you, I really do take any advice that you have to heart. So please, if you have a comment on what I could do better in this video to make this a little bit easier for you. I know my students keep saying these videos are too long, but I try and explain this as best I can. And right now, I'm not in class with my students, so I would just want to give them all of that detail. So sorry, Peyton, for making a long video. But I hope this was helpful. If it was, hit that like button down there and subscribe to the channel if you want to see more videos like this. I'd love to have your input too on what videos you'd like to see. So that is down in the comment section. And of course, I hope you have a great day. Make sure you keep doing math and do so carefully and with enthusiasm. Don't do drugs, folks. Bye, everybody.